So, welcome everybody. My name is Stephan Janssen. For the people who do not know me, I'm the Okay, sorry. There's the intro. For the people who do not know me, I actually founded Devoxx 23 years ago. And I run the Devoxx Belgium edition. So that's what I do. And luckily I can do this now as a day job. And the great thing about it is it's not a full-time job, so I can still do a lot of programming when I'm not organizing Devoxx. And most of the time, I'm basically doing research and development. I'm a developer, and that's what I love to do. So the talk I'm going to give you is basically some experiences I had on doing RAG development and large language model developments since about 2 years. Before that, I was already doing AI, but for my son, he plays basketball, and I was doing like camera recognition and creating highlights using neural networks to know where the highlights were in the game and to identify and track the ball and things like that. So just basically having fun with technology and talking about it. And so one of the things I actually developed is the call for papers application. So this is the CFP. It's an Angular application using Spring Boot for the speakers to submit their talks. And there the talks can be actually rated, reviewed, and then scheduled. And all the Devoxxes and Vox Days events use this application. And as a test, I developed a chatbot. But it's internally, as you can see, it says beta on the left, chatbot beta, and it was just for the organizers to see if this actually works. And so I asked the question, how many talks did Brian Getz give at Devoxx Belgium last year? And funny enough, it answered, Brian gave 2 talks. Okay. And then I looked into the database, into the application CFP, he actually gave 4 talks. So like, bloody hell, what's going on? And that was actually the trigger of this journey that I spent the last 6 months on figuring out what the hell is going on with the wrong answers. And there's like these many occasions where even like Air Canada, I think this is already like 8 months old, they actually had a chatbot as well, and they were able to actually create hallucination where the refund policy was invented. So people got like their money back even if it was not allowed. So that's like, okay, maybe that's not a good thing to put in production just yet. And it was clear, like even my chatbot, I did not put it out there for all the attendees to play with it because it is really hallucinating all over the place. And so Richard Feynman actually has this quote where he says, I would rather have questions that can't be answered than answers that can't be questioned, which doesn't fit completely in my philosophy. So I create my own quote. I would rather have questions that can't be answered than answers that are hallucinated. And this is really the biggest issue in getting RAG, large language models, into production. This is the issue. Please don't use it for mission-critical applications because you're going to get stuffed, to use an English term. You have to be really careful about that. And so, based on that, what I did is that I developed a prototype. And I deliberately called it a prototype to actually evaluate the RAG, the Retrieval-Augmented Generation approach, and to see where does it go wrong, what happens, etc. Now, this talk it's a more specialized expert talk. So if you don't know anything about RAG at all, I really recommend to go to these other 2 sessions. There's a deep dive, a 2-hour talk this afternoon at 3:50. Which goes really from beginning to end, and you will see all the codes that you want to achieve to do RAG, naive RAG, advanced RAG. And tomorrow morning at 9 o'clock, Liz is also giving a talk about innovation and how to use LangChain. But the 4 technologies that I've used, especially for the CFP, is Angular, Spring Boot, of course Java 21, and most importantly, LangChain for J. How many people have already heard about LangChain for J? Wow. So like maybe 7 people out of, let's say, 100. So LangChain for J was actually announced last year at Devoxx Belgium. They did the very first talk at Devoxx Belgium in October last year. And since then, it has actually exploded. And it's basically a Java API framework which talks to large language models, right? But in a very beautifully written code, uses builders. It's very intuitive, very, very simple to use. And that's what I've also used for this prototype. Now, the reason why I called it a prototype is that for prototypes, you don't have to develop unit tests. At least that's my philosophy, right? So I did write a few unit tests, but it's like, well, yeah, I test it on the UI and then see how it behaves. And it's open source, so if you stick around, you will get the link to the application, and you can play with it yourself. Now, let's first look at the possible RAG flow. There's actually a flow that happens. It's like a dance that you need to execute to accomplish a RAG implementation. Let me take you step by step. And as I've mentioned, every step, there's some code behind it, which you will see in the talk after this. But basically, this is the pattern that people use to actually accomplish a RAG implementation. So you have some content. Let's say you have some web pages, or you have some frequently asked questions, or you have even a REST interface, because that's what I used for my CFP. The CFP has a REST interface to get all the talks from a specific Devoxx, and it returns JSON. And so the first problem already was that the JSON that it returns was too big. So if you actually have document loaders, a document loader is basically, it takes a URL, it loads some content, and it gets the text from the HTML, for example, if it's a web page. It takes that content, and then you start splitting that content into chunks. And the reason why we do this chunking is that because a large language model has a limited window context. At least last year, 1 year ago, the context was like 4,000 tokens. And I'll come back to that one. So that's basically what you do. You get some content from wherever it is. It doesn't really matter what. It could even be images, right? Anything digital, you get the content, you load it, you split it, and then you embed it, which means you actually convert it into an embedding float array. It's basically a float array for most of the embedding models. I'll explain that in a bit more detail. And then the user asks a question, a query. This question, which is again text, is embedded with the same embedding model. Very important, always use the same embedding models, otherwise they can't talk to each other. And then it is placed into a vector database. This could be in memory as well. It doesn't have to be a persistent vector database. And then you do a similarity search. And based on where the vector is related to the other vector, the distance shows how close they are related or not. Right? And I'll give you more details going forward, even a few pointers of some interesting talks that you can still watch later this week. So that was already, that's what's called the naive RAG implementation. Now you can go a bit further. You can already introduce, for example, a web search where you say like, okay, I have my frequently asked questions of Devoxx, I have a web page of Devoxx, but maybe somebody wants to know who invented Devoxx. You won't find that, you will only find that on Wikipedia. So I might want to add an internet search. Now in LangChain4j version 0.31, there's something called Web Search Engine. And Web Search Engine allows you to either use Google or Tavily to do a web search. So it's basically an API wrapper around a web search. And the result of that web search can then again be added as a document loader, split it, and put it into your vector database. So that's one way of getting real-time, real data next to the web pages that already exist. The other thing you can do is use tools, which is called in LangChain4j tool specifications. So a tool, this is often called an agent. That's where the scary parts are. That's where you get goosebumps on your arm, because a tool could actually be a Java class method. It could be even a REST method. It could be another application that you talk to. So it is smart enough by using annotations to say like, you have a method, you annotate it with some extra metadata explaining what this method does. And by giving a description to this agent, the LLM will know that, I've got a tool in my toolbox which finds speakers, so I probably have to call this method, which is named find speakers, and the parameter is first name, last name. So it knows about, wow, it's first name, last name, and the person said, Brian gets, so I will use Brian and gets as the two parameters, and it will call that method. And that's like Terminator shit. That's really scary stuff because it knows how to call methods. So that's like, it opens up a Pandora's box because you can do like REPLs, you can generate code and then execute the code, you could generate unit test and then call the unit test using agents. So agents that's where the innovation is happening. So lots of excitement there. You have code agents, you have even SQL agents. So you can even have an agent which produces SQL and then it fires that on your production database. Now, what can go wrong? Right? Just think, if it's going to hallucinate, it might do some scary stuff as well, and you don't want to have that on your production database. So you go to the vector database, you do your similarity search, you get some results, and then what happens is that often you might also introduce a re-ranker. It's based on an algorithm called BM25, Best Match 25, and it will basically re-rank the results based on the query that you've asked. And this is very convenient because it will actually push the content which is more relevant to the question into a specific order. Now, the problem with the re-ranker BM25 is the LangChain implementation. It uses a commercial version from Cohere. And Cohere uses, you need an API key for that. So I don't like paying for stuff if I can develop it myself. So what I did is that I developed my own BM25 and actually made it available on GitHub. So if you go and if you take a picture of that one, you can actually use the BM25. Now the cool thing is, you guys probably go like, wow, he developed his own BM25. But it's like, if you have AI assistants and all these large language models, if you are already a senior developer, you become an expert developer once you have these AI assistants helping you, right? So you just become more productive. So what I did to make this happen, I took an existing Python code, talked to ChatGPT and said like, hey, convert this Python code to Java, and then I refactored it a bit. I had to change it a bit just to make sure that the unit test worked, and that was it. And then I dropped it, right? So if you go to GitHub BM25, you can see basically it does these lists. You have a question, and it will order it based on your question. But this is not using a large language model. That's the beauty of having this. It's using some other algorithms to actually get a good match between words and responses. So BM25, you can use it. It's optional. You don't have to use a re-ranker to do a RAG implementation, but sometimes it produces better results. So you have to play with that. And so once I have these similarity documents, I will actually include it in the prompt. So this is your prompt, your question. So the question is, how many talks did Brian Getz give? But I include all these chunks of code that it found in the prompt itself. So you're basically giving it a context for the LLM to answer your question based on what you're giving it. So you're basically saying like, hey, Brian gave talk X, Y, Z, and then the question is, how many talks did Brian give? And it says, well, you just gave all the chunks, so it's X, Y, Z, and it answers that. And this is like prompt injection or the window context that you are producing for the prompt to be answered. So that's the whole RAG technique, basically. Yeah? And then you give the prompt to an LLM, and you get some output. And then you think like, great, I've done RAG, I'm an expert, I'll talk to the boss, get a pay raise, because I'm now an expert. There's a bit more to this story already, because what if I then say, and the second question would be like, and did he talk about Java 21? And then, very important, did he talk about Java 21? If you implement your RAG like this, the LLM will not know who he is. There's no memory. It doesn't know about he. It doesn't know about the previous question. So what you need to add as a minimum is you need to introduce which is called the chat memory. So what chat memory does is that it's basically a list of all the questions that you've asked and the answers. And it will include all these questions' answers into the prompt. So that way, if you say, and did he talk about Java 21, it will know like, the previous question was, did Brian Getz, how many talks did Brian Getz give? So it knows that he is Brian Getz and it will answer it. And that's this chat memory. Chat memory is implemented in LangChain for J as well. It even uses a class called compression query transformer. What compression query transformer does, it will actually try to compress the result so it's less verbose. Because again, the window context is limited. So the more chat messages you add, the bigger your window context will be, the more it will cost you if you use a commercial cloud provider. And you want to make that compact. So you can actually use that class. It's optional, you don't have to, but you can, to make it actually a more compact window context so you get faster response and you have to pay less if you use a cloud provider. And then the last part is if you have an output, what you often see with these ChatGPTs is like these thumbs up, thumbs down icons, right? Well, this is basically saying to the system, yeah, that answer was good, or that answer was really bad, it was hallucinating. But if it's good, you can actually include the good answers into your knowledge base again, and then feed that into your RAG system, because if somebody else comes along and says again, how many talks did Brian Getz give? He or she might actually already have that answer in the knowledge base, and we can get that from the model and answer it. So this is, take a picture of this, because this took me quite a while to actually see how you should implement it. This is already a good basis. This is a starting point for a good RAG implementation. Yeah? So take a picture. What I didn't mention is already this one here, queries. You will not believe this, but when I asked how many talks did Brian Getz give, I was able to get 4 as an answer, worked. But when I did, how many presentations did Brian Getz give, I got a wrong answer. What the hell? So if I say presentations or talk, there's a difference and it gives a different answer? Come on, that's not acceptable. How can I fix that? There's no way of doing that. Well, it seems there is. It's called query transformer. So what query transformer does, it will take your original question, your query, and it will produce different variations of your query. So it will talk to an LLM and say, hey, give me 4 different versions of this question. So it might come with a question, how many talks, how many presentations, did Brian Getz speak at Devoxx, etc. And then now you have 4 queries instead of 1, and it will actually go through this loop for the 4 questions. Now, it's already very obvious. It's going to take longer. It's going to cost you more, but you will get the right answer eventually, right? But I think if you leave this room here, one thing you should remember is that a one-shot prompt will probably often not give you the right answer. You need to do multi-shot prompts. So that means you need to introduce a chain of thought, which means that you need to actually talk to the LLM, to the large language model, multiple times with different variations. And then often, the end result will actually be what you want, right? But not always, you do not always know what you want because you don't know the answer, right? So there's like different approaches. RAG is not always the best approach. I could have, with my question, how many talks did Brian Getz give? I could have used an entity extractor. And an entity extractor would take the name Brian Getz, and then I just do an SQL query, Brian Getz. That would have probably been easier than doing all this shit here, right? So you need to be a bit pragmatic. The problem is with the chatbot, you have no idea what they're going to ask. So you need to really anticipate all the different scenarios. And that's where I have not even included this in the slide. You need to introduce guardrails. Guardrails is like when you go bowling and you go with the kids, they put these rails up so the ball doesn't go off court, so it stays within the lane, right? Well, this is the same thing, philosophy. You have guardrails where you say like, okay, they can only ask about Devoxx Belgium. They can only talk about Devoxx Belgium 2023. And so you add these constraints in the prompt where you are limiting what the LLM can answer. And what's very important, you can actually then say in the prompt, if you do not know the answer, just say, I don't know. And just adding that sentence will actually already introduce a guardrail. Well, the LLM says like, well, I don't know about Gregor speaking at Devoxx Belgium, so it will say, I don't know, right? So this is really important. It's like, this is a bit prompt engineering, but playing with prompts. Like another interesting one is like, and I used to do that a few months ago. If you do not give the right answer, I will kill a kitten. I will kill a cat. And the LLM will do a better job trying to answer because it thinks you're going to kill a cat. All right? Now, don't use this anymore because in ChatGPT, if you do it, it will answer and say, this is against policy, this is against terms of use, you cannot kill a cat. We will reject you. Seriously, right? So what you can say instead is that, okay, if you give me the right answer, I will give 10,000 euros to a charity program, so please give the right answer. Right? Or I will lose my job if you don't give the right answer. Please. Seriously, I'm not joking. This really helps getting better responses. So it's like, wow, crazy times. So that was the flow. I will not show you all the code, but what I want to show you is a bit like how did I use it, what are the best combinations, etc. And these are the large language model providers that I used. So I used Ollama, LM Studio, and GPT-4All, which runs locally on your Mac. So privacy, no problems there. It all runs on your machine locally. I could have used Apple MLX, but that wasn't available when I started the prototype. And the cloud providers are the ones on the right. I did not use Gemini at the time because at that time there was no API keys available. Since Google I/O, they now have also API keys. So those are the ones you can play with. That's already interesting, right? So the first one is ingestion. I need to get the data into the system. Now the cool thing about LangChain4j is that there's already quite a few different classes available that you can use out of the box. So if you want to have text, HTML, PDF, even GitHub, and Office documents, it has all these loaders available. However, it does not have any loaders for JSON. That's why I ran into problems. It does not have any support for REST. It does not have any support for code. Now keep in mind, LangChain4j is actually a spin-off of a Python project called LangChain. So if you want to know what's going to happen with LangChain4j in the future, just look at the Python version. The Python version actually has code loaders. So you can actually say, load this document for this programming language, Java. And then it will split your documents and it knows that these are Java programs that you're giving it. So it will split it by class, by method, or whatever your settings are. So this is an example of how to load an HTML using a URL. Very straightforward. You create a URL source, you give it a URL, you create a text document parser, you load it, and then you do an HTML text extractor. And it's an open source project, so you can look what's being used. And they use JSoup. JSoup is a very well-known Java library and Python library as well, to actually get the content from HTML and not get all the CSS and the JavaScript and stuff like that. Cool. So we've got our data. Now we need to split the data. So the first thing you need to know is that, well, to split or not to split. People often do not know, why do I need to split it? Well, 2 years ago, the window context, the prompt context was only 4,000 tokens. That was the maximum you could give it, right? One token is on average 3 to 4 characters, right? So you have about 16 to 12,000 characters that you can give it into the prompt. This is the input prompt. These days, ChatGPT, for example, has 128,000 tokens. Even Gemini has 1 million tokens. 1 million tokens today available. So a lot of your projects, you can give your full project, your Java project or whatever project you have, as a window context and then ask questions. 1 million. They even have in the labs, they have already 2 million to 10 million window contexts. They are basically going to infinite window contexts. So you can give the whole books, for me it's programming, right? So you can give like 30,000 lines of code in one prompt and then say, okay, where's the bug? Do I have a security vulnerability? And this is called something called needle in a haystack. So you can use, what they do is that they put one specific information in that 1 million window context. You put one information line, and then you ask the question, and you see if the large language model finds the answer to that question. And it's this needle you put in the haystack, right? So if you look at this is an example of GPT-4 with a window context of 128,000 tokens, and it gets a bit less, it's a bit blurry, but it gets a bit less when you are adding when your window context becomes bigger and bigger. However, if you, I don't know if I have the slide, no I don't. If you would look at the Gemini one, which has 1 million window context, almost is green over the whole line. So you have a 1 million tokens, you put some information in it, and it will find it, which is like, that's crazy. Now do keep in mind, the cloud providers, they will bill you based on the number of tokens that you give it. So they will have a different billing. They will have a billing for input and a billing for output. So the output is the response. So based on the number of characters it responds, you will have to pay more or less, right? And these are just an example of how much it could cost. I mean, it can really range. I mean, it could be like $15 for a million window context on Anthropic, and then $75 for the output, if it's a 1 million output. Now, often the input is much bigger than the output. Often the output is much smaller and is reduced in size because you just need an answer like yes or no, or here is some sentences of a bug it found, right? So input is often bigger than the output. But what's very important to remember is that injecting the context, so the information that you include in the prompt, really helps reduce the hallucination, because you're providing it with the information that it needs to know the answer from. Right? So that's really, really important. If you want to go for production LLMs, chatbots, you need to make sure that the window context is as good as possible, because it will get its ground truth from that prompt, right? So splitting, there's multiple strategies in LangChain4j. You can split by character, by word, by sentence, and so on, even recursive, which is all of the above. And it's as simple as a simple switch statement where you just do an instance of that splitting strategy, and then you give it a text, you give it a chunk, how big the chunk should be, maybe the overlap, and it will then basically split the contents that you have passed it and use it in the prompt. There are some advanced splitting strategies. There are strategies based on the semantic meaning even. So it will not split on characters or words, but on the meaning. So it knows that if another paragraph is about something else, it will split there because it's about a different subject. There's a very interesting talk by Greg Kamrat. Take a picture of that and have a look at it. It's on YouTube. He spoke at Devoxx Belgium as well. He's a great guy. Very interesting. He explains all these different approaches, and there's people who are doing their PhD on this. I'm certain about it, because it's becoming very sophisticated how you split content. It's not just about a new line or a dot. It goes much further than that. So let me show you a demo of the prototype I've built. Like I said, it's open sourced. I spent a bit of time on that. So this is all the language models I'm using, so you can actually see all the different language models, the costs. You can see if based on the costs, on the context, etc. Then all the different embedding models I'm supporting. I've added actually quite a few since the last time we saw the talk, Loic. I've also added Gina, which is a very interesting embedding model. Gina is one which they have an embedding model, which I'll talk about later on, which is multilingual, but also for code bases, right? And so here in import data, you can import the data, either text, a web page, a web search, files, and whatever. And then you can do text splitting. So I've already imported some data, for example, the frequently asked questions. Then I can say, okay, split by paragraph, and the chunk size should be 500 characters, and the overlap 25. And then I say split. And then I can visually see where it is splitting. And this was already an eye-opener, because when I was splitting on the REST response, on the JSON response, it was splitting it right in the middle of a sentence. So that was already, for me, showing that, okay, it was splitting a sentence into two, and it was only taking one of the two parts. So as a result, my prompt context would be incomplete. So that's why a splitting context is really important. You need to choose the right one, because if you split it and it will not include one or the other, you will just have incomplete responses. And so then, once your splitting is okay, you can say store it in a database, which is a vector database, and then you can select your embedding models. So this is also, again, you need to do a bit of research which embedding models you want to choose, but I've implemented quite a few so you can play with it and see how your code behaves. And once that's done, it will actually create vector documents. This is really great because normally you don't get this. So these are all the chunks which are embedded and included, and it actually says which embedding it used, what the content is, and this is really important for debugging. Because if you normally do RAG, you do not have that information. You just have an array of floats, and you have no idea what it means. And for fun, I've also visualized it, and thanks to Alex, who's also here, I can now even go through the cloud and actually see what each model is. So like this group here, these are several talks on AI. So they're actually grouped together because they're all talking about AI. So this is the semantic meaning where it groups these different nodes together based on the semantic information. Cool. So Alex, thanks for your help. Where are you, Alex? Oh, there he is. Thanks for that. Really appreciate it. So that's already where you can play with it. So the vector store, you need to make a decision there as well. You can go into a database. You can do it in memory, but you could also go into a database. And there's a great talk about from Alex today. Is it right? Yeah? Yes? You should go to his talk. This is a slide from him, where you have all the different possibilities. And he plays, if you thought the vector cloud was impressive, you should see his talk. It's like he's doing next level. I chose to use Postgres and specifically PG Vector. So PG Vector is an extra extension to Postgres, which allows you to actually include vectors, but then do similarity searches in the database. The only problem which I've ran into when I was using this is that you can only go to dimensions of 2000. So you can't go beyond 2000 dimensions. And this is so you can only have, like the 512, 768, 1024 dimensions embeddings. But if you want to use embeddings from ChatGPT, which is like 3000 plus, it will not fit into Postgres. So you have to watch out for that, which was, I didn't know about this. So then you need to use another vector database. So talking about embeddings, that could be a talk on its own. Just how to embed content. So how to change text to a numerical representation which captures the semantic meaning. So if I have like, how many talks did Brian Getz give? In LangChain4j, I just need to use this one here. I need to get an embedding model, which is this embedding model, the default one, included in LangChain4j, called the Mini LM-L6v2. I say embed this text and get the content. And then the content, I can add some metadata to it. I can add it to a text segment. And I basically say, add this embedding into this embedding store. And it's now persisted. Depending on which embedding store you're using, it will be in memory or on disk. But basically, it's converting how many talks did Brian Getz give into this array of floats, right? And it's that's been used to actually do these similarity searches. And there's a whole range of embeddings. LangChain4j has some local embeddings, so it just runs locally on your machine. But there's also embeddings as a service. So you can go to OpenAI, Nomic, Hugging Face. Gina is a new one, very interesting one, which is multilingual. So multilingual support and also support for code. And there was also Cohere, which is multilingual. And the reason why I needed multilingual is that the CFP is also used by Devoxx France. And in France, they only speak French. So I had to have an embedding in French. And so in the beginning, it didn't work because I was using the old mini one. And so Emmanuel Bernard was like, qu'est-ce que ça? Ça marche pas en français, quoi? And it was just because I was using the wrong embedding. It was only for English. So I had to use the Cohere one. And so I developed a Cohere implementation because it didn't exist in LangChain4j, which you can find on this GitHub project. And the cool thing is that it actually got embedded in the project LangChain4j. So I'm now an official contributor to LangChain4j. So they included the Cohere embedding in the project. So if you need multilingual support, you will need to use that one. So embedding dimensions is important. You need to think about that. what is cool, I did not know about this, is that if you give a longer context, the local embeddings will actually split your context so it actually fits the dimensions. So you're not losing any part of your text, which was already one of the issues I had with my How Many Talks Did Brian Getz Give, is that there was a talk with 5 speakers, and Brian was the last speaker. And because it was cut off, Brian was not included in that talk, so we could never find that talk into the large language model answer. Like, what the hell? How could I know that, right? So by doing this prototype, I was able to see it visually how and what was happening. So you have to think about this. Embeddings, which embeddings, the size, the dimensions, the store, can it support the sizes, etc. And that's just what I've just mentioned before. And this is the example where it actually is splitting the embedding in the local embedding implementation. So that's a cool feature. I was not aware of this, and the founder of LangChain4j saw this talk, and he came back to me and said, "Oh, Stephan, it's actually like this." So I did this is the 3rd iteration of my talk, basically. Now, what's really cool with embeddings is by default, they use a float, 16 bits floats, right? What's now the trend is that they are starting to play and doing quantization. So instead of using a 16-bit float, they are now using integers. And why? Let's go to the extreme. Let's use the bits, 0 and 1. Now, how the hell can you have a semantic meaning with just a 0 and a 1? And it seems it's possible. So Cohere and Gina, So Gina and Cohere support binary embedding. The beauty of binary embedding, well, instead of 16 bits, we only have 1 bit. So the size is smaller. If you have to host it on a vector database, the storage will be much smaller. So it's going to cost less if you have a big corpus, right? But then you would go like, well, but doesn't it lose any semantic meaning? Well, it seems it actually doesn't. And this is just, you have even an unsigned binary and unsigned integer, so you can play with this. But what it seems is that the bigger the model size, the smaller the delta is between the semantic meaning. So if you're using a large language model which is above 100 billion parameters, there's almost no difference. However, if you have a smaller model, the difference is higher, as you can see on the chart here, so there is a bit of a loss. But these are things you have to think about. It's just not only which embedding, but which embedding type you're going to use. I didn't know that when I started. And there's some interesting graphs here where it actually shows. So the top one is a binary one, and then you have the normal ones using the floats. And you can actually see that, well, first of all, a binary one will have faster response because it's much more condensed, right? So compared to like 900 seconds and milliseconds, sorry, and 8 milliseconds. But also the accuracy, you go from 0.78 to 0.99. Now, sometimes that might be more than enough. It could be that 0.78 accuracy is more enough, is good enough for your use case. So you need to play with this as well. So you see, like, just doing a RAG, well, it's simple, it's just 5 lines of code, well, 10 lines to be precise. There's a lot more you need to actually look into and evaluate. And I told the founder of LangChain is that he does have a problem because his implementation of the embedding is all based on floats. So if I want to store integers or bits, sure, I can put it in a float, but like, yeah, what's the use then? It's still storing it as a float. So he will probably need to revisit this. So the last part I wanted to show, well, there's 2 parts left, but I wanted to then like evaluate the RAG. So I want to have like all these questions. I want to define what the right answers are, and then compare the responses and see if it's hallucinating based on this embedding model, this language model, etc. And this is where I do this evaluation. So let me go back to my prototype. So here I have evaluation questions. So I have a question, how many talks did Brian Getz give, and list them. And this is the correct list, so 4 talks and the number of and the title of the talks. And these are some tags that I'm looking for. And then I can actually execute this, so I can say, okay, use this one, start the evaluation. I can select the models I want to use, So a local model, for example, certain embedding models. So I can do multiple combinations. Then I can actually give it the similarity search, etc. So I can pass on all these parameters, and then I can start these evaluations. I will not do this because it takes a bit of time, but I can show you the results. Is that if I do here, you can actually see that OpenAI GPT-4 got 100% keyword match, and the similarity score is about 80%, which is good because I'm only giving titles and the response is much longer than that. But you can actually play with the different models and see how they respond. So depending on your use case, you can use this prototype to actually see what combinations work best based on the expected questions, etc., for your project. Cool. Still 9 minutes. I will skip this. So what are the lessons learned? Embedding models have an input limit. They also have an output limit. So you need to think about that. And there's a cost involved, right? So watch out for that. The bigger the embedding dimensions, the higher the hosting cost, but also often the better results you will have. So if you can go very high with the dimensions, you will get a better result. Multi-language is a thing. So if you want to do RAG in Polish, you need to find an embedding which supports the Polish language. I'm not aware of any, but you need to find out. That's some research you need to do. So quality of your embedding influences the quality of your results, that's for sure. Leverage and test the power of different LLMs. That's why I built this prototype. Play with all the different LLMs and different embeddings. It will have an impact on the quality, but also the cost, etc. You have to play with that. Debug and log your context. Very, very important, because otherwise you're just walking in the dark, you have no idea what's going on. Double check the vector database support dimensions. If you go to a vector database, go to Alex talk and make sure that it has the right dimension support. And definitely use a framework like LangChain4j. If you want to use Python, there's the LangChain project, also open source. There's also Llama Index, which is in Python, but also a very interesting Python project to follow and see what research they're doing there. Now, the question is, what's next? Well, for me, I did the opening keynote at Devoxx Belgium, as I always do, last year in October, and I had Anton come on stage from IntelliJ. And he actually announced the IntelliJ Assistant AI plugin. Who uses IntelliJ? Let's say 80% of the room, right? And he showed and demonstrated the AI assistant. And the question I asked him was, and you can actually see it from the transcript, are you going to support large language models which are open source and locally on my machine? Because a lot of companies, they do not want their intellectual property to be shared with a cloud provider where they will learn their model on your questions and answers, right? So you want to keep that on-premise. And he said, well, yeah, we don't know yet, and so on. And it took a while, and after a few months, I said, like, so what's happening? Are you going to support local models? He said, no, it's not good. I said, okay, fuck it. I'll write it myself. So what I did, I built my own plugin for IntelliJ, which is called Devoxx Genie. So Devoxx Genie, it's an open source plugin. It's free, and it works with all the local models and the cloud models. So if you want to use only local models, fine, just install them and it will work. But if you don't care and you can use cloud, you can mix and match them. So let me demonstrate that to you. And this is not a commercial because it's free and open source. So what I'm begging for is pull requests, right? Look at the code, change it, adapt it, find bugs, whatever. But this is Genie here on the right. So this is the Genie box. And the cool thing is that I can go to the settings and I can add my local models. So I have Ollama, LM Studio, GPT4All, and Jan. So these are running locally on my machine. And I can provide all the API keys for cloud providing LLMs. And if I provide all these API keys, they will get listed here in the dropdown. So I can choose from all these. So I could go, like, for example, to Ollama, and then I get all my models that I have locally on my machine. Now, the cool thing is, this is really, I find it really fascinating, is that I can select one model. So I had this question here, I think yesterday afternoon when I was in Frankfurt on the plane. I had a curl that I wanted to convert into Java. So I gave a curl request. I said, write it in Java. And I used a local model. So I used Olama. I'm not sure, I can't zoom in. I used Olama code Gemma, and it gave me this code. And then I changed the LLM, and I used a cloud provider from Anthropic, used Cloud Opus, which is one of the best, and basically said like, hey, the previous response, so I'm using chat memory, right? The previous response wasn't that good. Can you review the response from this other model? And say, oh, okay, yeah. So it looked at the response. It's now giving me another example. And then I gave the example from Opus and selected another cloud provider here. Here, you can see it, OpenAI, GPT-4o. And that one took the previous messages, looked at it, and then came with the right answer. So by talking to 3 different LLMs, 1 local, 2 clouds, I got the right result. And now I can be really productive because like I have an expert system helping me, and I'm already a senior developer, so I'm even more productive. Isn't this cool? See, I get goosebumps, seriously. My hair is like going like, this is just crazy. If I'm on the plane, I don't have internet, I can work with local models and still be productive and talking to an assistant. How should I do this? How should I do that? Hey, review this, write a unit test, etc. And so this one here, the model allows you to actually add files as well. So I can add files and basically populate my window context. So you're selecting the files that you want to include in the window context and then send it to the model. Now, the things I'm going to do, because it's almost summer holidays, so that's the most productive time of the year for me, I can actually include the full project. This plugin is like I said, it's only 127,000 tokens. I can send the whole project to Gemini or ChatGPT and say like, hey, I want to develop this feature. How would I do it based on the context you have? And I'm discussing, because I work at home alone, I have no pair developers next to me. So I'm using this basically as a pair developer to help me and understand what I can do. It's just crazy times, seriously. It's like, bloody hell. I mean, it's both exciting and frightening at the same time. It's like this superposition quantum states. You really don't know where it's going to end. So this is an example of, you have LLMs talking to each other and help. Some LLMs then actually say, hey, that response was really bad, it should be like this, etc. So the Devoxx Genie, I've basically shown you this. So it does all of this for the moment. I even have streaming support. I'm even using the abstract syntax tree. If you enable it, it will take the abstract syntax tree of the class that you have open in your editor. It will see that it extends from another class, so it will include that class in the window context so it has a better understanding of what you're trying to do. So there's all sorts of crazy things you can do. It's open source, have a look at it. The next thing I really want to do is RAG support. So I would love to have a real, this is the talk about RAG, I should use RAG. The problem is, how does IntelliJ support, local storage? If I want to have a RAG, do I need to use a Docker instance or not? Or do I have to go to cloud, etc.? Do I do query routing? Do I use different? As you can see, there's a lot of different questions you need to ask to get a very good response, and it's actually not that easy. There's a guy from Devoxx France who's going to build also a Visual Studio Code one, which is in TypeScript, so great. Auto-completion, I personally don't like that. Like if you do tap and it auto-completes some garbage, I prefer to have it, give it in the window context and discuss it. I prefer that type of approach. That's why I did not yet implement it, but maybe somebody here in the audience might do this for me, who knows. And that's basically it. So these are the links to the projects, and thank you for your attention. I'm here still 3 days, so if you want to talk to me, come to me, don't hesitate. Thank you.